Today we're going to look at what an object is in Java. We're going to learn about how to program it and a little bit of just the basics of what's going on behind objects. In the future videos, we're going to be talking about constructors and access modifiers and getters and setters and stuff like that. So stay tuned for those other videos. But for now, we're just going to talk about the basics of objects. So what is an object? So an object is a code representation of something else, right? That's a very nebulous explanation, right? But let's do an example here. Let's say, for instance, I wanted to make a student manager program. So I'm going to make a program to just manage students and maybe tracks attendance or something like that. So what would I need for student information? Well, I would need something that's like string first name. I would also need to have string last name, okay, so things like that. I might need to know their grade, which is that's grade like 1 to 12. All right, and maybe I would need to know their GPA, so which would be a double, so their grade point average, meaning their actual marks average. All right, so the problem with this is, this is fine if you're representing one student in the program. But let's say I needed to make a program that represented many, many other students. Well, the problem is with this is that it's very difficult to use this to represent many students. In fact, what I would probably do is just put it into an array and make 4 arrays. But that creates another problem. If you do these in arrays, anytime you did a swap operation on one array, you would have to do the same swap operation on all the other arrays as well, right? And whenever you modified certain things in one array, you'd have to make sure and be careful that you never mixed up elements, because each element is representative of one student in that array. So instead, what we can do is we can actually just create a student object. And the student object, as I said, is going to represent this student in our code. Right, so how do we do that? Well, we go to make a new class, right? And in this class, we're going to call it a student. Now, keep in mind, we did not create a public static void main, so there's no main program in this. Okay, so here's our student object, and all it says is public class student. So that's it. It's just a student. Well, what is a student? Well, what we do is we take these, okay, and put them here, and what we call these are class attributes, okay, or variables. Okay, so these are the class attributes or class variables, and these represent what a student is, okay, so what a student is made out of. All right, so when we go back to the main program now, we can actually now create a student variable. All right, so what is a student variable though? Okay, so up to now, you should be understanding that you can have like integers, right, doubles, stuff like that. But now you can create a student variable. Okay, so I can say student, I don't know, I don't want to call it student. I feel like that syntax is kind of it's confusing. So let's just call it some student. Okay, so you have student, it's just some student. All right, now when I do this, this creates a name for a student. But it doesn't actually create a student. In order to create an actual student, what we have to do is we have to use the new command, right? So we would say new student, like that. And what this does is it creates a student, okay, or a student object. Okay. Now, the act of creating a student object, okay, so I'll put this in comment here. The act of creating an object is called instantiation, right? So we are instantiating an object. And what that means is we are making an instance of the object. This is a weird type of terminology that most people have a difficult time with at first, because up until now, you typically don't talk about like instances in this way. What an instance is in computer science is just an example of, or one creation of an object type. Right? So if I had 5 different students, I would have 5 instances of students. And in order to create those, I would have to instantiate the instance 5 times, right? So I'd have to instantiate the student 5 times. All right, so here we have student, some student. That creates a name. Now, when I say new student here, this creates a student object, but the problem is, because it has no name, Java's garbage collection feature will just come by and destroy the object, right? So, because it'll say you don't have a name, then you go to the garbage. So what we have to do is, when we create a new object, we usually just attach it to a name like this. Okay, so we have some student, or student, some student. That creates the name. Then we have new student, which creates the object, and we have the equal sign, which it just attaches the name to the object. All right, so this is creating a reference to the object, and now we have a student called some student. All right, now, just so you know, we could also do something like this. Student Bob is equal to some student. And what this does is it creates a new name called Bob, and what it does is it attaches it to the student that we created over here. So how many students are there? Well, there's actually only one student in this program. That's the new student we created here. It has 2 names though. The first name it has is some student, and the second name is Bob. So when I'm talking about Bob or some student, I'm talking about the same object. All right. We're just not going to do that. It seems kind of trivial about that. Like, you think, like, why would you do that? But this feature is actually used quite a bit in programming, especially when we start with data structures and we start moving stuff around or swapping or things like that. Because it's important to remember, if you ever take the name away from an object, so it has no name at all, then it will get garbage collected and get destroyed and returned back to the system. Right? So you must be careful never to dereference your objects unless you really want to get rid of it. All right. Now, be aware also that in other languages, such as C++, if you dereference an object, so you take away all its names, in C++ it will not get garbage collected, and it will just sit in your memory and use up your RAM, and that is called a memory leak. Right. So once you have a memory leak like that, and you have this object just sitting in your memory, you can't get rid of it because there's no way to address it, and so you can't actually get rid of it, and it just eats up your memory. Right, so that should also be avoided as well. All right, so we have student, some student is equal to new student. That's great. Now, how do you access the parts of the student? So let's take a look in math. If I give you pi, what does the 3.14 mean? Well, specifically, what does this decimal mean? Well, the stuff on the left side of the decimal is whole items. Okay, so this means we have 3 whole items. And the 0.14 means we have partial items. So we have 14 1/100ths of a full item. So these are parts of full items. A similar syntax is used in programming. So if I wanted to access just a part of the some student, what I would do is I would say some student dot, and then I could choose which part I wanted to access. Okay, so let's say, for instance, I give it a first name like this. So I say some student dot first name is equal to, and I'm just going to pick a name at random. Let's say Wendy. Okay. Now I don't have a student named Wendy at this time, so this is just a random name I chose. If I happen to have a student named Wendy at the time when you're watching this, it's just a coincidence. It's not. I didn't pick them for any particular reason. Right, this is just a name I chose at random. Okay, so you have some student dot first name is equal to Wendy. So what would happen if I said sysout, so system.println, some students dot first name. Okay, so we have some student. Well, what's a student? Well, a student is these 4 things. It's made of a string first name, a string last name, an integer grade, and a double GPA. So it should say Wendy. Right? So let's run this, and there you go. It's Wendy. Now, a lot of people would think, and this is a common thing for people who are beginning to program with objects, is they think that the name, when I say some student first name, that it would print out some student. Right? That's the object name, not the attribute value. Okay, so we have an attribute called first name, and so when I say the first name is equal to Wendy, I am talking about the attribute first name, all right, not the object's name, right? So this is the variable name in the program, all right? Now, interestingly, what would happen if I just print out some student? Okay, let's go take a look. Okay, and what we see here is we have in the code, there is a student. Okay, so code is the package. Okay, so my package is called code over here. There is a student object, and this is located at 368.239C8. And what this is a memory address. So it is telling us that this object is located, it is a student, and is located in this memory address. All right. Now, typically, we will work with that later, especially when we get to link this. But for now, we're going to just do this. So SumStudent.firstName is equal to Wendy, and then we print out the first name, and we're able to change the variable like that. Okay, now that we can create students as an entire variable all by themselves, then if we wanted to, we could make arrays of students. So you could say student array, and you could say many students is equal to new student array, and say there's 1,000 students like that. And you could do the same operations like shuffling, populating, shifting, like reversing, anything like that that you would do normally with any other array, right? And you wouldn't have to say student.firstName is equal to student B.firstName, like student A first name is equal to student B first name. You could just say swap student A with student B, and it would just swap them. All right, well, not exactly like that, but you don't have to swap the individual parts, you can swap them as a whole. All right, and that is the basics of object-oriented programming. Okay, it allows us to create essentially our own variables and be able to package them together like this into one complete object, right? And then what we can do in our code is we can work with each individual object, and we can work with its individual pieces, but to the computer treats this as if it is its own thing. All right, that's it for this video, but in the next video, we're going to go on and we're going to talk about access modifiers, and yeah, we'll talk about why we use them and how we program them.